want to talk about equivalent rates. Okay, so take two scenarios, two banks. One bank offers you 5% per year as long as you leave your money in for 5 years. Another bank offers you, they basically say to you, you leave your money in and at the end of 5 years, we will give you 25% of your money extra. Which bank is better? Or are they the same? Okay, a lot of people think they're the same and the banks can end up getting preferentially selected when they're actually not as good as another bank, but they sound good if you don't know your maths well enough. So let's look at the 5% per year for 5 years. That means if you put P in for 5 years, at the end of the 5 years, your P is going to turn into P times 1 plus the interest rate as a decimal to the power of the number of years. Okay, now that turns out to be P times 1.05 to the power of 5. Quick calculation, 1.05 to the power of 5 is, that's equal to P times 1.276. All right, now let's look at the other bank. In the other bank, you put in P. They're just telling you that after 5 years, you get 25%. So in other words, we're going to add 25% on after 5 years. So to add 25% onto a number, that means you multiply the number by 1.25 or 1 plus 25 as a decimal, percent as a decimal. Which bank would you prefer? The multiplier here is 1.276. The multiplier here is 1.25. So hopefully you can see that this is better. So 25% after 5 years does not equate to 5% per year for 5 years. This is a percentage after 5 years. If we want to figure out what percentage does that equate to on a yearly basis, if it was compound interest, then this is what I want to show you next, okay? So we can see that 25% definitely does not equate to 5% per year compound interest, okay? But the question is, what does it equate to? Okay, so the proper way of phrasing that question is, we want to know what is the annual equivalent rate of 25% over 5 years. What's the annual equivalent rate of that? Okay, so what you're going to do is you're going to say, well, we'll call the annual equivalent rate R. Okay, so we know that if we put P in for 5 years and we were giving an interest rate of R every year for 5 years, we know that what we would get out at the end of the 5 years would be P times 1 plus R to the power of 5. That's what we'd get at the end of 5 years. We want to find the R so that this number is this number plus 25%. So in other words, what the bank was saying is you put in P and over 5 years we will give you out P times 1.25. Okay? So what R would end up with you getting that 1.25? Basically, we want to equate these two numbers. So P times 1 plus R to the power of 5 needs to be equal to P times 1.25. How do we find R? Well, we can divide by P and we get 1 plus R to the power of 5 is equal to 1.25. We need R, so we need to get the fifth root. So 1 plus r is 1.25 to the power of 1/5, or the fifth root, whichever way you want. And r would be equal to 1.25 to the power of 1/5 minus 1. Now, what does that give us? That's 1.25 to the power of 1/5 minus 1, which is 0.04563. That's as a decimal, so that is 4.563%. So what we're saying there is the annual equivalent of 25% over 5 years. That is the same as offering you 4.563% per year annually compound interest over the 5 years. Okay? Now, as a general number, instead, if we want, let's do this without the 25% now, if we just call it R. Okay? So if we have a P, and we are told, for instance, that the yearly interest rate is 8%. That means if I put P in at the end of 1 year, I will get P times 1.08. Now say I want to know what would the monthly equivalent rate be. Monthly equivalent rate. What do I mean by that? I mean that if I put P in and interest is added on every month instead of every year, we call the interest rate R actually. So if the interest rate is added on every month for 12 months, then I want to know what would that monthly rate have to be in order to make me end up with 8% of what I added on to what I had at the start. So I know that if there's R% every month being compounded, I know at the end I'm going to get P times 1 plus R as a decimal, which is R over 100, to the power of 12. So again now I want P times 1 plus R as a decimal to the power of 12 to be equal to P times 1.08. Divide both sides by P. 1 plus R as a decimal to the power of 12 is equal to 1.08. 1 plus R as a decimal is 1.08 to the power of 1/12, getting the 12th root of both sides. R as a decimal is 1.08 to the power of 1/12 minus 1. Again, what does that turn out to be? 1.08 to the power of 1/12 minus 1 is, which is equal to 0.00, 1.08 to the power of 1/12 minus 1, which will give you 0.00643, which is 0.643%. So what are we saying there? We are saying that if we put money in at the start of a year and we get 0.643% added on every year compound, or every month compound interest for the 12 months, that at the end we will get out 8% of what we put in as our extra. Okay, so in other words, compound interest of 0.643 added every month is exactly the same as 8% added over the full year. And again, you can check your answer by saying 1p times 1 plus the interest rate 0.00643 as a decimal to the power of 12 should give us something very close to 1.08. So 1 plus, so 1.00643 to the power of 12 gives us P times 1.079999948. Okay, I rounded it a little bit down here, so that's why we're not getting the exact number. Okay, hopefully that will have shown you how to get the annual equivalent rate or the monthly equivalent rate, whatever way the question is asking you. And again, the very general form of that is if you have P and over a particular time frame you get out P times 1 plus I, if you want to work out, say, if you were putting the interest rate over a small time frame, if you were compounding it over smaller time frames instead, and you want to find the equivalent interest rate to give you the I at the end here, then in this situation, if we say there are n of these r's, so we won't say there's 5 of them, we'll say there's n of them, we know that what we get out here at the end is P times 1 plus r as a decimal to the power of n. And what we do is we say P times 1 plus r to the power, r as a decimal to the power of n, has to be equal to P times 1 plus I. Your two P's divide out, and what you have is 1 plus r as a decimal is equal to 1 plus I to the power of 1 over n. Because you have an n here, so you get the nth root of both sides. Okay, and that's how, if you want to find an equivalent rate, this is how you do it effectively. Okay, hopefully that makes sense. I can do a couple of questions as